disjunction with R. This indicate that. Okay, and that is quite equivalent to if we do that Q disjunction R, then with the solution of this part, if we do the disjunction with P, that is also same thing. Okay, then this particular property is known as associative, and it is also valid for conjunction also, conjunction operation also. Now the property distributive. In the property distributive, if you are writing like P disjunction Q R, then we can write okay, we can write like this. It is quite similar to our normal mathematical term, like A multiply, if we compare this thing, sorry, then we can write AB plus AC. Okay, it is quite similar to that one. Okay, like that. The other property is De Morgan's law. It is very renowned popular law, which is also you can go it is also available in digital logic design, and like negation. Okay, it is equivalent to, if you open up the braces, then the sign will be reverse one, change. That means conjunction become disjunction. Okay, it is quite similar to logical like sorry, you can simply learn this part as a break the line, change the sign, like that. Break the line at the middle and break the line, change the sign. We can easily remember this part. Okay, okay, the other two properties are absorption and negation. Okay, thus all these property indicates the logical equivalence when the both two different statements with several operations, we can make them equivalent. Okay, during the representation of facts into the logical representation, sometime you may see these symbols are used in those statements to represent some facts. Then we can, by applying these rules, or we can say these properties, we can convert them into logically equivalent statements. Okay. Okay, in the propositional logic, till now we have gone through several statements of logical representation. In the propositional logic of the logical representation, in the propositional logic, some disadvantages are there. Like if we consider some complex statement, for us it's very difficult to convert them, the complex facts, into the propositional logic statements. And like here you can see some statements, sometimes it present, we cannot represent in the propositional logic. Like in our real life, if we consider some of the boys are interested in playing, okay, or statements like all the boys are interested in hockey, those time of some, all, or those types of facts we cannot represent in the propositional logic. That is the other major disadvantage. Here two statements are given: all girls are intelligent, some apples are sweet. These, especially these type of statements, we cannot represent in the propositional logic. Okay, this is one of the major disadvantages or of your propositional logic. The other disadvantage, it is having some limited expressive power. Limited expressive power means, like, if we consider one statement, all men are mortal. Suppose in this classroom all men, all men, if we are considering them as a mortal, okay, one statement is suppose given in the okay, this is a fact, all men are mortal, and if we convert into propositional logic, suppose we are indicating or representing mortal man. Okay, if the statement all men are mortal is true, it is not sure that each and every individual man is a mortal. Okay, suppose in our classroom I am saying that all the students are intelligent, and parallelly I am picking up one random student and I am saying that that particular student is intelligent. It doesn't indicate that may not be true. That means if all the students in the classroom are intelligent, and when I am representing that statement in propositional logic, that doesn't indicate that each and every individual, each and every student is intelligent. Okay, that is the major disadvantage, another disadvantage of propositional logic. Okay, so just to overcome all these limitations available in the propositional logic, we will come up with another logical representation, first order logic. Okay, and it is sometimes known as predicate logic also. The first order logic is sufficiently expressive to represent natural language statement in concise way. Okay, in the day-to-day life, what are the statements we use in our day-to-day communication, or the facts? Those facts are easily we can represent in the first order logic, and it's have comparatively it's have more expressive power. First order logic does not only assume that world contains facts like propositional logic, but also assume following things in the world, like objects. Okay, object include A, B, people, numbers, colors, word, theories, anything you can consider. Then relationship, it can be unary relationship such as a red round is adjacent, and any relationship that in the set theory you might have gone through the many to many relationship, one to many relationship, many to one relationships, or some our human relationship also we can consider. Brother of A is brother of B, B is sister of C, like that. All those things we can consider over here. Then functions, father of, best friend, like that, all those things we can consider in this part. Okay, just let's go through one example. This is a very renowned example. Okay, look at the first fact. Marcus was a man. Here, while representing in the first order logic, just remember one thing. First of all, we need to identify the predicate. Predicate means that particular property, particular characteristics available in the fact. Here, Marcus was a man. Man here we can consider as a predicate, as it is indicating some character, man. Okay, and the representation is like, you can write the predicate man, then inside that you can write the name of that particular person, Marcus. Okay, in this statement, man is a character, that is predicate, and inside the bracket Marcus, that Marcus is a man. And here if we replace, if we change Marcus with X, that means it indicates that X is a man. Okay, similarly look into the next statement, Marcus was a Pompeian. Same thing, you need to find out the predicate. Here the predicate is Pompeian, Marcus is a Pompeian. Look into the third statement, all Pompeians were Roman. Here see, this is the representation for all X, and suppose X is a Pompeian, then we can say that X is also Roman. Okay. Okay, now look at the fourth statement.